Okay, so in this video, we will do this question, house robber, and it is a medium level question. Okay, so you are a professional robber planning to rob a house. So to do this question, you would have to be a professional robber. So along a street, each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent house have security system connected, and it will automatically contact the police if two adjacent houses were broken on the same night. Okay. Given an integer array nums representing amount of money of each houses, return the maximum amount of money you can rob tonight without alerting the police. So question is easy. We have to rob. We have to rob some houses. But what is the constraint that if I rob this house, I cannot rob the adjacent house to that house. Okay. Suppose if I rob first house, then I cannot rob second house. I will have to rob third house or any other house, not second. Okay. If I rob first house, apart from second, I can rob any other house. Okay. So this is our constraint. Suppose let me take this example. Nums is equals to 1 2 1 2 3 1. Yes. So if robber robs this one house, then he can only rob this third house. He cannot rob this two. He can rob this one as well, not third also. But the constraint is that you cannot rob the adjacent house. Apart from that, you can rob any house. So that is okay, easy condition. So if I rob one house, then I cannot rob the second house. I will rob third house. If I rob third house, then I cannot rob this one house. So my output is what? 3 plus 1, it's 4. Yes, it is 4. So here, if I rob first house, I cannot rob this house number 7. Means the amount of money this house has is 7. See, it is written there. Each house has certain amount of money, which is this, represented by array. Okay. Okay, so adjacent houses. Okay, see, nums representing the amount of money each house has. So easy. So if uh, if I rob the second house, I will rob this. Then I will rob this ninth house and then one. So 9 plus 2 is 11, and then 11 plus 1 is 12. That is our output. So I'm taking this example, copying this and taking this to my TL draw panel. And yes, so what will happen? Okay, so okay, so this is our houses. These are our houses. So I am taking them out from here. Let me draw these 2 7 9 3 1. Okay, 2 comma 7 comma 9 comma 3 comma 1. Okay, and their indexing. I'm also doing their indexing from red color. Okay, not from red, from green color. 0 comma 1 comma 2 comma 3 comma 4. Yes, this is the index of each house. Now, suppose if I'm a robber or you are a robber, you will try to rob this. See, whenever this is a DP problem or recursion problem, and whenever this type of problem comes to you, always take the first three cases of that problem. What are the first three cases? These are the first three cases. I have taken these. So, if I want to find maximum robbery till second house, the maximum robbery till suppose I am you are a robber or you are robbing this first house. Okay, so how much amount you can take from this house. So you only have, suppose you are in a village and you only have one house. So you'll rob that, and whatever money will that house have, you will take that. So money that this house has is 2. So maximum money I can take from this first house is 2. Suppose there are two houses in the village. So there's a condition. If I rob this, I cannot rob this. If I rob this, I cannot rob this. So what will you try to do? You will rob that house which has more amount of money. So if you compare these two houses, which has more? 7 has more. Means second house has more money. So you will rob this. Okay. And you will get 7 money. You will not rob this. You will not rob 2. You will rob this 7. Yes, you will rob the 7 and you will not rob 2. Yes, perfect. If see, uh, oh wait, yes. So if this happens, I will rob this and I will not rob 2. Okay. Suppose there are three houses now. Now there are three houses in village. So I have a choice. If I rob this, I cannot rob this. Okay. Then I can rob this. If I rob this middle house, then I can not rob both the houses adjacent to it. Yes. So this is the condition. So if I have three houses, what I will try? I will try to maximize my profit. Suppose first house has 2 money and third house has 3. Third house is 9. So they will give me total amount of 11. Suppose if you are a robber and you have houses like this 2, 7 and 9. Okay, I'm drawing them. So I will first rob this house. I cannot rob this. Then I will rob this. So total amount this is giving me is 11. Total amount this whole thing is giving me is 11. Yes. Now if I do opposite to this, suppose if I not rob this and I rob this, then I cannot rob this. So total amount this giving me is 7. The previous one was giving me 11. Which is more? 11 is more. So I will go this 11 path. So how to find? Now I'm writing a formula to do this control y. Oh, wait. 9. Yes. So if I want to maximize my profit till here, I will take both of them. I will do what? I will check. See, this is n. So this is n minus 2. N minus 2. So I will check maximum profit till n minus 2 plus 9. So maximum profit till n minus 2 was 2 only. So 2 plus 9 is 11. Okay. Comma. Maximum profit till here. See. Comma. Maximum profit till 7. So maximum profit till 7 was 7 only. See, maximum profit till 7 was 7 only. So which is maximum in these both? I will take that. So this is maximum. So our answer is 11. Suppose now maximum profit till 9 is 11. 9 is 11. Now I am at 3. If I am at third index, what will I do? I will check maximum profit till 7 plus comma maximum profit till 9. Okay, 7 plus 3. Maximum profit till 7 was 7 plus 3, that is 10. And comma maximum profit till 9, till n minus 1 house. So which is more? 7 plus 3 is 10. 10 is more. Yes. So we'll choose this. And see, if you have only 4 houses, 2, 7, 3, 9, and you have to maximize profit, what will you do? Or you have to go to 3. So see, first I will choose 7 house, then I will go to third house. Okay, this is giving me maximum profit till here. Okay, so no, wait, we are wrong here. We are wrong. Why? Because maximum profit till 7 plus 3, this is 10, and maximum profit till 9 was 11. So this path will only give me maximum profit. And see, same with 1. If I am at 1, I will check maximum profit till 9, that was 11 plus 1, comma maximum profit till 3, that was 11 only. So which wins? This wins. 12. I will get my amount. So now I'm going to write its code in C++. Though I always write my code in JavaScript, but this time C++, no problem. So I will write a function. So let me calculate its length first. Okay, nums dot size. Yes, perfect. So nums dot size. That's how we calculate length of any given array in C. Okay. So now I will create a unordered map. Why I'm creating this unordered map? Because this is my DP. Okay, unordered underscore map int comma int. This is my DP. DP is what I will store. See, I'm doing this question by using recursion. I have seen that most of the people do it using array, and that is a easy way. But DP is a recursion based technique. Okay, the classic DP was recursion only, not iteration. DP was only made for recursion. Okay, though we can do it using iteration, that is perfectly fine. But try it using this recursion. This is good technique. So I will return a function rob house. Yes, rob house. This will take n minus 1. See, this is my fourth house. 0, 1, 2, 3, 4. This is fourth index. Okay, length minus 1 is the index. So I'm passing n minus 1, comma. I will pass my nums array, nums vector, comma. I will pass my dp map. So that's all I need to pass. Now I am making this function and I'm doing this like okay. Let me do one thing. Int int rob house. See, int rob house int see, in this int n. This n is what? This n is the size minus 1. Okay, and vector nums underscore wait, vector of a integer underscore name is nums, or I'm taking its name as array. That will be easy to write. And an unordered map, unordered un. Okay, UNORDERED underscore map of int comma int, and its name is DP only, let's say. So we have done our thing. So see, I'm writing this and I'm passing these by reference. Why? See, I'm passing this and because in DP, because I want to change this map which is inside drop. I have to change it. So I'm passing it by reference, or I'm getting it by reference. Yes. But I don't need to change any array. Then why I'm passing this and? Because this will stop making copies of ARR in each recursion call, and that will save our memory and time. Okay, so that is it. And now what will I do? uh, if n is equals to 0, I am at first house, so maximum robbery till first house is what? Maximum robbery till first house is uh, maximum robbery till first house is return, not return, it's return. ARR of 0. Yes, perfect. If I am at first house, n is equals to 1, then maximum robbery. See, uh, let me make this clear. Yes, maximum robbery till I will return re-ruin, not return. So I will return ARR of what? See, maximum of both. Maximum one or second house. If suppose I have only two houses in a village, I will rob that house which has more money. So max of ARR of 0, comma max of uh, not max, it's ARR of 1. Yes, which one has maximum amount? I will drop that one. Yes, perfect. And now if my DP not has, see, though I should write the recursion first then optimize it, but for saving time I am writing recursion condition here only. If DP dot, see, till now for now forget this DP, just see what I am doing. Left is equals to not left, I'm not using JavaScript, I forgot. Left is equals to, for now forgot this DP, this if condition, focus on this left. rob rob house what with n minus 2, and let not let int priv. Okay, priv is equals to rob house with n minus 1. Yes, perfect. So these are my two conditions, and I will dp of n is equals to max of rob house, not rob house, left plus ARR of n, comma priv. Yes, this is my condition, and I will just do return dp of n. That is it, and I'm writing something here. Hash include wait, include, again wrong, include, wait, hash include std, not std, bits slash std c plus plus dot h. I'm using name space space std. Yes, perfect. So this is my code, and let me see, I'm telling you what is this left. This left is this. Suppose I have this 127 wait, 127 9 11, 127 9 11. Okay, and I am at this index. So left is this. Left is maximum robbery till here plus this. Okay, 127 9. Okay, 0 1 2. Okay, so 27931. So that 27931. Okay, house was 27931. 27. Wait, I'm writing it like this. 27931. Yes. So these are my houses. So max. See, if I'm here, I will check maximum robbery till here plus one. So this is my left, and this is my priv. Okay, this is my priv. This is my left, and this is my priv. this is priv, and this is left. So left plus array of n. Array of n is what? 1. So left plus 1, comma, maximum robbery till 3. Which one is max? Take that. That is what I'm doing there. So think it once if you cannot solve it. So I'm running this code and I'm, oh, wait. I can see an error. See, this function is taking 3 things and I'm only passing 2 things. So I will just pass this array again and this DP again. Yes. And here as well, this AR again and this DP again. So this is the first error I can see, and if this happens, I will do. And see, I should not do it directly like this. DP dot find n. I'm finding n is equals to dp dot end. Dp dot end means uh, we couldn't find. Okay, it was not there. So then do this. Otherwise, return dp of n. So now I think this is good. This looks good to me. Okay, again an error again. So that error is where return rob house dp. Okay, here. So now I think this was the last line and give me error here. So now this code will run. I think return rob house. Okay. It is giving me the right output, and if I run it, this should give me the right output. And see, the quality of C++ code which I like the most is that, see, it is running in 0 millisecond, it takes less time, and as well as it takes less memory in the system. The same code I tried with JavaScript, and that was taking 50 MB of spaces, 50 approximately 58 MB. See, it is taking 10.58, it was taking 58 point something MB storage. So that's why C++ is memory optimized, because it is deeply connected with that memory, let's say. So, and JavaScript is not. That's why. And its runtime is also less than JavaScript, though JavaScript code was also running in 0 millisecond for this question. But still, I have seen it in many questions. So that is the thing that I have seen, and this is the code for this question. So thank you so much. That was my approach, and you can do it according to you. You can use that iteration approach as well. It is also good. But I wanted to tell you using recursion, and you will on YouTube as well. You will not find many videos of this recursion. That's why you will find many videos of iteration. Thank you so much.